This is a medical news broadcast to make you aware of recent developments. It is important to understand that this is not medical advice. Hello and welcome to the Medical Justice News Brief. Thank you for joining us today as we bring to your attention a recently published study on the objective detection of chronic pain perception. Do we finally have an objective test for chronic pain? Recently, a group of researchers in the Department of Anesthesiology and Perioperative Care in the Division of Pain Medicine at the University of California, San Francisco, reported a groundbreaking discovery in pain management. They claim to have found an objective test that confirms the presence of severe chronic pain. But let's dive into the details. Physicians have long been searching for a reliable way to detect and track chronic pain and its response to treatment. But so far, they've come up empty-handed. Traditional measures like pupil size, blood pressure, heart rate, and affect have proven unreliable under scientific scrutiny. The authors of this study recognize the immense suffering and debility caused by chronic pain, which has been notoriously difficult to treat. They also point out that our current measure of pain, the self-reported 0 to 10 scale, lacks objective confirmation from any other measure. So how did they tackle this challenge? They started by taking 4 patients with severe refractory neuropathic pain and implanted chronic intracranial electrodes in specific areas of the brain related to pain perception. These areas included the anterior cingulate cortex and the orbital frontal cortex. The ACC and OFC play significant roles in brain networks like the emotional regulation network and the reward and decision-making network. They are also involved in the pain processing and perception network. These networks help regulate emotional responses and monitor decision outcomes. The participants reported pain metrics correlated with direct neural recordings taken several times daily over several months. By analyzing the neural activity in the OFC and ACC using machine learning methods, the authors successfully predicted the pain severity scores reported by the patients through text messages. Interestingly, the OFC showed distinct sustained power changes that could be distinguished from patterns created by transient acute evoked pain states. These evoked states were produced using transient heat stimuli of varying intensity on different body parts. The OFC activity appeared to be a more consistent predictor of chronic pain level perception than the ACC. This correlates with another study that used EEG to evaluate the resting state of brain activity in chronic pain patients compared to a control group. The results showed connectivity correlations in specific frequency ranges and global network reorganization in those suffering from chronic pain. A machine learning algorithm was also able to differentiate between patients and healthy controls based on the frontal lobe activity, but not to the same statistically significant level as the implanted electrodes. These studies open the door to the possibility that, in the near future, physicians may be able to non-invasively record brain activity to correlate it with chronic pain perception levels and track improvements after therapy. Now the challenge is to find a less invasive method than surgery-implanted brain probes to achieve this. And this brings us to MEG. MEG, or MagnetoEncephalography, offers improved spatial resolution and sensitivity to cortical activity compared to EEG. Both have excellent temporal resolution, but MEG's accuracy in pinpointing the source of brain activity is far superior. The downside is the cost and inconvenience of MEG, which relies on superconducting quantum interference devices, also called SQUIDs, which must be cooled to extremely low temperatures using liquid helium. However, there's hope on the horizon. We are exploring the possible use of high-temperature superconductors like rare earth barium copper oxide ceramics in MEG devices. These superconductors can operate at liquid nitrogen temperatures, making MEG more accessible and cost-effective. The future looks promising. With more affordable and accessible technology, we might revolutionize the field of pain medicine. Imagine being able to non-invasively record and track chronic pain levels, and using this data to ultimately improve the lives of countless patients. In conclusion, while we're not there yet, the quest for an objective test for chronic pain has taken significant strides. As technology advances, the medical community moves closer to achieving this goal. Thank you for watching, and stay tuned for more groundbreaking discoveries in the world of science and medicine. And if you found this video informative, please like and share it. And don't forget to subscribe for more thought-provoking content. A link to the studies can be found in the description. Thank you for listening, and let us continue to strive for a healthcare approach grounded in the latest research and guided by empathy and individual understanding. Until next time, take care and stay informed.